All right, so this is the notes for an isosceles triangle. You guys might have learned this a while back, but now it's just bringing in a couple of algebra in there, more difficult problems once we throw equilaterals. But anyways, equilateral triangles have basically two functions. You need to have at least two congruent sides. You can't have more, but you need to have two congruent sides in order for it to be considered isosceles. If you have three, then that's considered to be an equilateral. Anyway, so you have two congruent sides. So notice we're talking about sides, and then you also have two congruent angles. So basically you have two pairs of congruent stuff. The way I like to see it is basically there goes this angle, this side is equal to that side. And then you have basically the angles that are, if you want to say across the sides, you can go ahead and do that, but that's really just what it means. If you notice, in this first triangle that I'm working with, right, and this one right here, you can go ahead and see which sides are congruent and which angles are congruent because it says it there, x degrees, and then the two little tick marks. If we go ahead and go down here to this other triangle, notice how there is nothing about angles, but since you have this right here, since you have the two tick marks indicating two sides are congruent, we can automatically assume also that two angles are congruent. All you have to do now is basically decide that it's the opposite angles. Okay, so that's what I like to do. I kind of always like to, you can draw the lines if you want, so you don't really have to, but there you go. And then notice how on this one, this side has two tick marks. It's only to indicate that it's different than the other two sides. Then if we go ahead and move on to this last triangle, basically you see everything there just like in the first one. All right, you have your two tick marks here, so that means those two sides are congruent. And then you have your two angles, which are opposite your congruent sides. Okay, that's how it always works. If you notice, I really didn't say anything about this angle up here, this angle up here. This one here says it's 90 degrees, but whatever, right? It's just, the whole point is it's not the same as the other two angles. And then the other two angles, they're equal to each other. So let's go ahead and go and see another set of examples that are pretty easy, but just to, get it out of the way. So for instance, here in this first one, right, let's call this one 1. You have the 90-degree angle. Notice how this angle, the 90 degrees, is not a part of the ones that are congruent, right? If we go ahead and do our little highlight, and then we draw our arrows, then that means this angle is congruent to that angle. And so what that means is I can go ahead and put a little x there as well. So you can do it a couple of different ways. You can set up your equation and solve, or you can sort of just, use what you know, that a triangle is always equal to 180 to get your answer. And so since we have all three angles, we can go ahead and set up an equation. It'll be 90 plus x plus x. I added the three angles in the triangle, and I know it's equal to 180. Right after you go ahead and you can solve it, you'll get 90 plus 2x equals 180. Subtract 90 on both sides. We'll get that, and then we divide by 2. So x equals 45 degrees. The other way that I was saying that you could do it is, well, let's see, you have three angles. One of them is 90, and this angle is not the one that is congruent. So what we can do is we can do 180 minus 90. So what this means is this 90 degrees is split up into these two congruent angles. Since they're split evenly because they're congruent, we can go ahead and divide that by 2, which is then equal to 45 degrees. Same exact answer, but just solved it a little bit differently. For number 2, we go ahead and we do the same thing as before, right? This side is congruent to this side just based off of the tick marks. So then I can go ahead and draw my congruent angles based off of the side. So it'd be this angle is congruent to that angle. If you notice, x is already there. So what that really just means is x is congruent to the angle there. So it'll be 66 degrees. So that one's a little bit easier, right? The second one, but pretty straightforward method. We can just go ahead and move on to a little bit more difficult problems. This one here, I think the setup is the reason why a lot of people consider this to be difficult, but it's really not. So what we can go ahead and do, same thing as before, my two congruent sides, and so therefore my two angles that are congruent would be this one and that one right there. So we can set up our equation. So we know that one's equal to 77 degrees as well. So we can go ahead and do 77 plus 77. There goes our two congruent angles. And then plus, you can say angle 2, but then that's why they gave you that information there. So instead of saying, measure of angle 2, we actually know what it is. It's x plus 38. Since we added all the three angles of a triangle, we know that's equal to 180 from previous videos. And then we can go ahead and just, combine like terms and then subtract on both sides, blah, blah, blah. So we can go ahead and we can just do this really quickly. 77 2 times plus 38. So 77 plus 77 plus 38 is equal to 192. And then we go ahead and we subtract that by 180, right? Because we're doing it on both sides. And so then we can go ahead and that's equal to 0. X is equal to, is that negative 12? Yeah. Now, I know you're probably thinking like x is a negative. How can that work when we're talking about angles, right? If that's what you're thinking, that's a really good sort of thing to think about. But if you notice here, let's go ahead and let's think about this part right here. Measure of angle 2 is equal to x plus 38. If I substitute this answer into here, I get negative 12 plus 38, which is equal to a positive 26 degrees. So what that means is that angle 2 is equal to 26 degrees. Notice how the negative sign, it didn't make an angle negative. It was okay because 38 is bigger than 12. So we still get a positive answer, okay? So don't really freak out about that. Sometimes that can happen as long as you're doing the work correctly. So let's go ahead to the next example. Same thing as before. You can go ahead and see if you solve this one by yourself, but pretty much the steps are the same. Two congruent sides right there. So then my two congruent angles are the ones opposite. Since we have 40 here, I can go ahead and put 40 there as well, and then just set up my equation. I'll actually show you a different way of doing it. So if we notice, both of them are 40, so that means these two combined are equal to 80 degrees. Since I know a triangle is equal to 180, I can go ahead and I know that that one, by definition, has to be 100 degrees in order for everything to sum up to 180. So that kind of just saves me a couple of steps. So I know that measure of angle 2 has to equal to 100 degrees, right? Because the other two are 40, and we know it always has to add up to 180. So we could go ahead and do minus 1 on both sides. 9x equals 99. And then we divide by 9 on both sides. And then we get it up. So if you notice, pretty much same thing. I just solved it a little bit differently. I just saved a couple of steps there. But it is completely up to you how you want to do it. So now we get to... it looks more complicated, but it's not. Notice how there's extra lines in there, right? Notice this arrow, that arrow. Just focus on what you know. Focus on the fact that you still have an equilateral triangle right there, okay? So equilateral triangle, an isosceles triangle. So an isosceles triangle has two congruent sides, and so therefore it also has two congruent angles, okay? So that means this one is also 65. The only reason why this one's considered to be hard is just because how it looks. It's not that it's actually anything new or different. So 65 twice because those are the two congruent angles, and then x is equal to 180. You can go ahead and solve this, super quickly. Bring down your x, bring down your 180. 65 and 65 is 130, and then we subtract on both sides, and there you go. X is equal to 50 degrees. So the only reason I went ahead and I put this example is just because it looks harder. Some of you might, freak out, but it's pretty much the same thing. So let's go ahead and move on to the next one. And now this one, yes, it looks harder, and also because it is harder. So pause the video, give it a try, and see what you get. Same thing as before, right? We still have two congruent sides because we're working with equilateral. So that means this angle is equal to that angle. Now you have to be very careful here, right? Because you're talking about the angle that's on the inside. And if you notice, x is talking about the outside angle. Okay, so don't confuse that. You got to be very careful. So what you want to do first is actually try to figure out this red angle right here, this one, and then we can sort of, using that, figure out the x. So based off of isosceles definition, we know those two angles are congruent, so then I can go ahead and put 34 degrees there. And now what I'm going to go ahead and do is just draw this right here. I'm basically only going to draw a part of the picture. So this is what I'm going to go ahead and do. I'm going to put 34 there, which we just figured out. Okay. And so then we can go ahead and notice how these two angles together form a linear pair. So what that means is that the equation that I can write is 34 plus x is equal to 180. Now, this 180 is not because the triangle is equal to 180. This 180 is because you're talking about a linear pair. Okay, so you need to be careful about that. Then we go ahead and subtract 34 on both sides because, you know, that's how we solve equations. And then that's x is equal to, what is that, 146? Yeah, there you go. Okay, so x is equal to 146 degrees. So yes, this problem is a little bit, you have to basically slow it down. Slow it down, just give it a try. Don't make up your own rules, right? Think about what we did. First thing I did was I put 34 degrees on that angle, not because I'm making up a rule, but because it's an isosceles. After that, I went ahead and I drew the straight line there, which focuses the x, and I noticed that it was a linear pair because it's a linear pair, and from previous videos, previous lessons, last year, you know that a linear pair always adds up to 180 degrees, and then we can go ahead and we solve. Okay, so you're going to start noticing that the examples are going to get a little bit more complicated looking. It's not that, you know, you have to do anything new. You just have to incorporate different concepts here. So let's go ahead with this one. We have that isosceles, and then we have this isosceles. Notice how the yellow has one tick line, and then the blue has two tick lines. That means that they're different side lengths. You can't just assume that they're the same, right? The one tick mark to the two tick marks. What we can assume is that this angle is equal to that angle, and we know that this angle is equal to that angle. Notice again that I'm doing different lines because we don't know that they're the same, like the red is equal to the blue, okay? So I can go ahead, I could put, let me go ahead and actually use the same color. So I'm going to put 54 right here because that's what we know congruent means. So both of those are equal to 54. Now you really have to think about, well, how can I somehow get over here to this angle that is on the other side? You have to pass another triangle. Well, you can figure out that angle right here, this missing one. And we do it just by understanding, you know, a triangle, all the angles of a triangle always add up to 180. So we have 54 two times. And I'm not going to call that one x because we already have x there. So let's just call it, you know, a different letter. It doesn't really matter. You just have to stay organized. So let's call it y. So plus y is equal to 180. I can go ahead and solve that by, you know, combining like terms, blah, blah, blah. I think what is that, 109? No, 108, right? 108, and then we subtract 108 on both sides. So that is equal to, what is that, 272? Yeah, 72 degrees. So we know that this one right here on the inside, where it had y, we know that one is equal to 72 degrees. Now, how does that help us? Well, you really have to think about it and look at the diagram. You have there, right here in the middle, right there in the middle, you have vertical angles. Okay, so what that means is that you can go ahead and this 72, you can actually incorporate it in there as well because we know vertical angles are congruent. So right there, we're using vertical angles. Okay, and so now we somehow figured out an angle inside the other triangle. based off my blue tick marks, I know that since that one is 72, this one over here is also 72, which you can't really see. So let me go ahead and just erase this so we can see it. So we know this one is equal to 72, and we know this one is also equal to 72. And then same thing as before, I'm going to go ahead now, and last thing is we see a linear pair there. If you can't really see it, I'm going to go ahead and draw it. So we have just this line where we have x right here and we have 72. Okay, that is just this right here zoomed in. Okay, and then we have a linear pair. So then finally the last thing to do is to go ahead and set up my last equation, which is 72 plus x is equal to 180. This 180 has nothing to do with a triangle. It has to do with the fact that you're working with a linear pair. We subtract 72 on both sides, and then x is finally equal to 108. Now I know you're thinking, well, we already had the 108 before, why didn't we just do that? I just didn't know that it was going to come out to be like that, okay? Do the work. It's okay. Think about the steps that you're doing, right? Steps that you've already known for a while. So let's go ahead with the next example. The same thing as before. They're getting a little bit more complicated, so you're going to have to slow it down. Okay, so for this one, we're going to go ahead and start with, you have to really start where you have numbers or we have information. So if you noticed, this here is where you have information. That is considered to be a linear pair, the 119 with the angle inside here. Okay, that's really bad. So that's a question mark. So anyways, let's go ahead and let's start there to basically figure out what that angle inside that triangle needs to be. So doing that, it's a linear pair, so we know 119 plus, I don't want to use x because x is already used in the equation, so we'll use y. 119 plus y is equal to 180 degrees because it is a linear pair. Okay, and then we solve this, we would get subtract 119 on both sides. Let me just do it for those of you that need it. So we subtract 119 on both sides, and we would get, what is that, 61. So what that means is that this angle right here in the inside is going to be equal to 61 degrees. Okay, and then we can go ahead now and start, looking at, well, I have an isosceles. So this right here is considered to be an isosceles because it has two congruent sides. And so by, drawing my arrows opposite, I can automatically know that this is also 61 degrees because for an isosceles, you always have two congruent sides and two congruent angles. And so then we have this right there. Okay, 61 degrees, 61 degrees. Now, one really thing I want you to notice is that even though these two angles right here are congruent, I don't know that they are also congruent to these two over here. Now, I can see that it is also using one tick mark for the other triangle, for the one on the bottom. But notice how they look different already. You're talking about two triangles, one that sort of has this sort of opening versus one that is a little bit more, like inside or squeezed in. So even though they have the same lengths, they do not have the same angles. We can't assume that. They probably could, but we would have to show the work for it. So in order to figure out what the angle is in the second triangle, the one on the bottom, the first thing I'm actually going to do is see if I can figure out that angle right there. This one right here, the one that's missing for that triangle on the top. And it's a pretty easy process because we've been doing it frequently already. So two angles equal to 61 degrees. So then that's going to give us 122 degrees, both of them together if we were to add them. I know that a triangle always has to add up to 180. So I can just very quickly do 180 subtract 122, and that's going to end up giving me, 58 degrees. So what that means is that 58 is going to go basically up here. It's going to be this angle, the one on the inside of the triangle for the triangle on the top. And so we can go ahead and start, using stuff that we already know. If you notice, sorry about that. Let's go ahead and let's think about this here. That right there is a 90-degree angle, and it was basically separated into two angles. Notice how I'm not saying like bisected or split into two, because we don't know if it's split into two evenly, right? It's obviously not, because one of the angles is 58. So to figure out the bottom angle, to figure out basically this angle here, all I'm gonna have to do is basically focus on this, which we know that is a complementary because it adds up to 90 degrees, right? We see the little red box there. And so I would just go ahead and I'll do 90 minus 58. That's gonna give me 32. And so that means that the angle right here on the bottom, right, that angle is going to be equal to 32 degrees. Okay, and so now we actually have an angle on the inside for the bottom triangle. And so it's really nice because we can now go ahead and use the fact that these are isosceles, that's an isosceles triangle. So that automatically means that this angle is congruent to that angle. Since we already know that the other angle is 32 degrees, I can go ahead and do one of the tricks that we've been doing before. So if you want to, you can solve it using an equation, or you can solve it sort of like how we were doing over here, this work. So a triangle always is equal to 180 degrees. This angle right here used up already 32. Okay, so what that means is that you're gonna have 148 degrees left over. So those 148 degrees need to be split up into two angles, basically to do this angle here and to do that angle on the inside. So we can go ahead and do 148 divided by 2, right? Because I'm basically splitting it in half now, and I can do that because they are congruent, and that's going to end up giving you 74. Okay, and so now what we can do is I can go ahead and I can start filling in this this triangle with the correct number. So 74, we know this one is 74, and I accidentally erased it. We know this one over here is 61. Okay, and so the really nice part about it is that we're almost done, because we wanted to get X and we have that information there. So I'm gonna go ahead and redraw this part over here, sort of like if you're zooming in. And so redrawing it, I end up getting the straight line and then this line right here. So that'll be X, and then we have 74 degrees right there. Okay, and so what I can go ahead and I can do is I can, using the fact that they're a linear pair, I can just, make my one last equation or solve it depending on how you want to do it. And so we have, if this angle here is 74 and we know that the entire thing is equal to 180, then we would just have to do 180 minus 74, and then that'll be our answer for X. So if we just do that work, it's going to be, what is that? 106 degrees. Okay. So after all that work, we get X is equal to 106 degrees. I know it's a little messy, but go back, replay this example. You basically, all we did was just basic stuff. So let's go ahead with the next example. I'm going to do this one a little bit faster, but pretty much it's the exact same idea here, okay? So first thing I'm going to go ahead and do is always start where the number is at. So we see the 64 here. I am going to notice that you are working with a vertical pairs there, a vertical angle. So that means this one is 64 degrees automatically because they're vertical angles, and we know vertical angles are congruent. And so what I can go ahead and do now is focus on the triangles. So we have an isosceles there. Looking at the angles opposite the sides, I know that this angle is congruent to that angle. So that means that one I can also write 64 on it. So that's what I'm going to go ahead and do. Now I'm going to go ahead and notice how right here in this section where there's the X and the 64, I cannot do that they're a linear pair because they're not. If you notice, it goes straight and then it sort of curves up a little bit. So this is not a linear pair. Okay. it had to be a straight line in order for me to do that trick, okay? So that's why I cannot do that. And so the next thing that I'm going to end up doing is I'm going to end up trying to figure out what that angle on the top is in order to then figure out this angle here. If you notice again, the little red box. So therefore you're talking about complementary angles. Okay. So let's do that right now. 64 and 64 together give me 128. Triangle is always equal to 180, and so then all I would have to do is do 180 minus 128, and that's going to end up giving me what is that, 52 degrees. That doesn't even look at 2. Okay, so 52 degrees, and so that means that the angle up there is 52 degrees. Since it's a complementary angle with the other one, since the little red box, I can go ahead and do 90 minus 52 to get this angle right there. And so then doing that work, I would end up getting, what is that, 38 degrees. Okay. So that means this angle right here is equal to 38 degrees. Now the last thing I have to do is really just, you have isosceles there. So what that means is that this angle right here, the one we just figured out, the 38, is congruent to this one, again based off of the arrows. And so that means this one right here is 38. And now just to figure out x, since it's inside the triangle, I can go ahead and just do 38 2 times. And that's going to give me 76. And I know a triangle has to always equal, when I add the angles together, it always has to equal 180. So I just subtract that from it, and it's going to be equal to 104 degrees. So right there, that's what x is equal to. Okay. If you really need it, I would suggest you go ahead and you set up your equation where this is how it would look. 38 plus 38, those are my two angles that are congruent, plus x, which is the angle that's missing, equals 180 degrees. Because, you know, if you add 3 angles in a triangle, it always adds up to 180. And so you solve this the exact same way, you know, combine like terms, blah, 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 isolate your variable. X is going to be equal to 104 if you do it correctly. Okay, so that there is my answer. So let's go ahead to the next example. Okay, so let's go ahead, let's start this example. And so same thing as before, we're going to start with our isosceles triangles just to find which angles are congruent. So since those two are my congruent sides, that means that this angle right here on the bottom, the 73, is congruent to that angle there. So then we know that this one is also 73. And then we can go ahead and figure out what the angle is right here that's missing, right? That little one on the top, by doing 73 and 73 together. And so that is 146. If we add 73 and 73, we can go ahead and do 180 minus 146 to get that missing angle there, the one with the question mark. And that's going to be equal to 34 degrees, I think. Yeah, 34 degrees. And so then we can go ahead and we can write 34 degrees in there to help us out, right? 34 degrees. Same thing as before, we see that there is a right angle there, so complementary, meaning that in order for me to figure out this bottom angle here, I can go ahead and do the whole 90 minus 34. You can set up equations, right? You can do 34 plus, you choose a different variable. You can choose y or something. 34 plus y equals 90 and then solve, but you're pretty much going to be doing the exact same thing. And so this right here is going to be equal to 56 degrees. So I'm going to go ahead and write that in there as well. So it'll be 56. So those two together give me 90. So that works. And now if you notice, if we come down to the bottom triangle, we have an isosceles again, meaning that the two angles right here at the bottom are equal to each other, or they're congruent as well. I don't have a number right now for them, but I can definitely go ahead and set it up. So let's do that. Where's it? Okay, so we already used up 56 degrees. So what I can go ahead and do, and I can do 180 minus 56. So that's going to give me, what is that, 4, 1, what is that, 114? 124. Yeah, it should be 124. Okay. So then we end up getting that these two angles here together, if I were to add them, they would equal to 124. You can go ahead and create your own equation, right, where you would basically add 5x minus 3 2 times and then set that equal to 124. But I'm going to go ahead and just do like sort of the shortcut version, which is if I know both of them together equals 124 and I know they're congruent, I can just divide them evenly and then that'll give me what each angle is equal to. So technically each angle is equal to 62 degrees. So that's what I figured out right there. So each one is 62 degrees. And now this here saves me a lot of time because if you notice, I put 62 right over where the 2 is at. So what that means is that this is equal to 62 degrees, okay? You have to do the work for this. There's no way around it. So technically this is the super important equation you need to basically solve. We go ahead and we isolate the variable by adding 3 on both sides. And that gives me 65. That doesn't look like a 5. Equals 5x. And then we divide by 5 on both sides. And so x is equal to, what is that? 113. Okay. And so then there you go, the direction. So you find the value of x and there you go. So all these problems, you really just have to get a little bit creative sometimes. The only reason this one is considered difficult is because of the expression. So let's go ahead with the next one. Let's see if you can figure this one out by yourself. Pause the video and try to do it by yourself. So trying to do this problem, you can go ahead and do it a couple of ways. But the way I'm going to do it is focus first on the fact that this here is a complementary. So I'm going to go ahead and figure out the other angle, the one that is attached or adjacent to the 44. And so I'm going to do that by doing 90 minus 44, which ends up giving me, what is that, 36? Yeah, 36. And so then that means that this angle right here is 36. Now I can go ahead and focus on this right here. Now, if you really think about it, you have to have an end goal. Now, my end goal is trying to get that angle because then I see that you have a linear pair here, okay? So always have that in your head. Like, why are you doing this step? Like, why are you, what's going to be the, how is it going to help you eventually, okay? So that's my end goal, getting to this angle, okay? After that, I know what to do next. And so looking at what I just highlighted, you see that it's an isosceles. So what that means is that this angle is congruent to that angle. So I know this one is also 36. And so now we get into a really basic problem where you have two angles in a triangle and you're missing one of them. So 36 2 times, all right? So 36 2 times is going to give me 72. 6, 7, yeah, 72 degrees. So what that means is in order for me to figure out this missing angle, I'm going to go ahead and do 180 minus 72. And so that's going to end up giving me 108. And let me go ahead and just continue the problem now, right? I'm going to go ahead and put 108 there. And I think you can definitely notice that it looks not drawn to scale, right? Because 108 is almost 90 degrees, just like 18 degrees off. But yeah, so we have that 108 there. Now, finally, the last step is to go ahead and do my end goal, which was I have a linear pair. Okay, so I have this linear pair right here where I have the number 2 right there and I have 108 degrees. Okay, since I know this is a linear pair, I know that this has to be enough to give me the outside. So basically this needs to be equal to 72 degrees. Now notice how it has a different name, which is angle 2. Okay, sorry, that was supposed to be an arrow. There you go. So what I can go ahead and do is I can set this equal to 72 degrees, and then there you go. That'll give you my answer at the end. So I can go ahead and do x plus 101 is equal to 72 degrees. And then we just solve for it, by isolating the variable. X is equal to negative 29 degrees. And now I'm actually not going to put the degrees there. I'm just going to put negative 29 because we can go ahead and when we plug it into here, we will get back a positive angle. So I'm just going to put negative 29 there. Go to the next example. Isosceles triangle, two congruent sides. So automatically two congruent angles. Now, notice how I have no numbers whatsoever, but I do have expressions. So I know that these two angles are the one that need to be congruent, okay? I went ahead and I did the little red marks. So the only thing I do know is that it's equal to 4x plus 1 because it has to be congruent to the other one. And so now I have all three angles in expressions, but it doesn't matter. I still know that it has to be equal to 180 degrees, okay? I sort of skipped this step, but let's just read the directions and say, determine the measure of angle E. So I actually want to know what this angle is equal to, but an actual number, not just the expression. So that'll be our final answer, okay? Notice how it doesn't say solve for X. It says, what is angle E equal to? The measure, okay? So an actual number. So let's go ahead and based off of what we know that 4x plus 1 plus 4x plus 1, there goes my two congruent angles, plus 5x minus 4. All three of those have to equal to 180 because we're working with a triangle, okay? So then, combine like terms. You guys know I like to draw the lines. 4, 8, and 5 is 13. X, and then 1, 1, and negative 4, that's equal to negative 2, is equal to 180. And then we go ahead and we solve, add 2 on both sides. We get 13x is equal to 182. And then we go ahead and we do 182 divided by 13 on both sides, which, yeah, no, I don't have that memorized. X is equal to 14 after plugging into my calculator. And now some of you, this is where you're going to, sort of stop, feel really good about yourself, and you should if you're able to get to that point. But you gotta read the directions, okay? It doesn't say solve for X. It says find the measure of E. So what you do is you go ahead and you plug it back in, okay? That there now is going to be our final answer. So plugging it back in, okay? So we have 4. Now x would go there, but we know x is equal to 14 and then plus 1. 4 times 14, that is equal to, what is that, 56? Plus 1 is equal to 57 degrees. So there you go. Okay? Sorry, yeah, that just looked wrong, but whatever. Okay, so now the final answer is 57 degrees. This is the final answer, okay? Not x is equal to 14, so just be very careful. Okay, now, most of the examples, in fact, all of the previous ones had to do with angles. So now let's go ahead and let's see a couple of examples with side lengths, but it's pretty much the exact same thing. If you're good with angles, then you're good with side lengths. So the first one here, if you notice, yeah, there's not even any direction. Sorry about that. Let's say solve for x. Okay. So if you notice here, there's only expressions. You have no numbers whatsoever. Your angles, it doesn't even have numbers. But we're talking about side lengths. So let's go ahead and let's slow it down. You have two angles that are congruent because the picture told us, okay? So I didn't draw that, right? It was already there. Notice how they have the exact same amount of lines, so that means they're congruent. And so now you're sort of going in the opposite direction. Since you have two congruent angles, that automatically means you also have two congruent sides. So that's sort of how you would solve this, okay? So once again, you have two congruent angles, so it automatically means that the two sides opposite are also congruent. Notice how I drew my arrows. They're going in opposite direction because it's from what I am given. That's what I can start assuming. Okay, that's why they come out of the angles. And so what that means is that these two sides are congruent. They're equal to each other. And so we can actually set up a really simple equation. We can say they're equal to each other. That's what being congruent means. Okay. And so we would just solve this. You can decide to solve it whichever way. Remember, it doesn't matter which way you isolate the variable, which side you isolate it. You're trying to avoid working with negative numbers, so that's why we would move the 2x, but it doesn't really matter, let's be honest. I'm going to go ahead and do it in one step, right, just to show you that you can. So that's equal to 1x is equal to 12. Now you can go ahead and, I know some of you guys are going to divide by 1, but whatever. It's going to give you 12 still anyways. So x is equal to 12. I know I did that a little bit fast. For those of you guys that need to, solve it one step at a time, move the 2x first, then bring everything down, and then move this -6. Go ahead and do that, okay? But you're still going to get the exact same answer. So let's go ahead with another one. Now, this one is actually missing some information. So let me go ahead and let me draw it. So let's see. The perimeter of the following isosceles triangles, 45. Solve for x. Let's go ahead and let's do this one 2x minus 1. And let's do this one 10 inches or whatever, okay? All right, so notice here how in the directions I tell you that the perimeter is 45 inches, okay? So what does that mean? A perimeter is when you add all the sides together and it'll give you 45. So let's see what this is going on here. So we have two congruent sides, so I can go ahead and automatically know that this one is also equal to 2x minus 1. Let me use a different color. Okay, so 2x minus 1, just because of the diagram. And then we know nothing about the angles, except probably this is equal to this one, but that doesn't really tell us anything, right? It could be pretty much like any number it wants to be as of right now. And so then we have to use what the directions gave us. Perimeter is when you add all the sides together, and then we know it's equal to 45. So let's go ahead and let's do that. So 2x minus 1 plus 2x minus 1 plus 10 is equal to 45. You could have done this another way as well, right? You could subtract 10 from 45 and then divide that by 2 and then set that equal to 2x minus 1, if that makes sense. If it doesn't, then let's just go ahead and keep doing it this way. Let's combine like terms. So we have that right there. So 2x and 2x, 4x, -1 and -1, and 10 give me a +8 equals 45. I believe you will get a decimal here, but I'm not entirely sure. So 4x is equal to 45 minus 8, which is equal to 37. And there you go. Yeah, you'll get a decimal. And then 37 divided by 4, because that is the last step. X is equal to 9.25. Now you can consider this to be inches, right? So x is equal to 9.25 inches. Okay? And so then let's go ahead with the last example. So let's see, the perimeter of triangle QRS. So we're talking about perimeter again. If we add all sides, is equal to 344 centimeters. Okay, just information. The measure of angle Q is equal to, okay, so that's your first problem. And then QR. QR is really just saying what is the distance between Q and R. So you're looking for the side distance or an actual number for that. So we would, if you notice, it says y plus 31. After we figure out y, we would have to plug that in. Okay, so that right there is the notation. Let's go ahead and let's see what we can do. So looking at it, we have an isosceles triangle. Looking at it, that means this angle is congruent to that one because those are the opposite. Okay. And so then that means what I can go ahead and do is I can say this is 68 as well. I'm almost to this first part, the angle Q, which is this one. Notice how I'm putting two lines there because I do not know that they are congruent, and in fact they're not, to 68. What you can do as well is you can just also do a different color, right, just to basically indicate difference. But even with that, let me just do two just for, some colorblind people or whatever. So I'm going to go ahead and figure out measure of angle Q first because I basically did all the work already. So I know 68, it's twice, and so these two together is equal to 136. And then I also know the sum of a triangle, of all the angles in a triangle is equal to 180. So if I go ahead and I subtract that, that's going to equal to 44. Yeah. So boom, I have my first answer, 44 degrees. Okay. So now let's go ahead and let's work with the sides. Okay, so we're done with the angles. Working with the sides, we see two little tick marks. So that means that this is also equal to y plus 31 centimeters. And then we have y for the last one. All the sides together is the perimeter. So if I add them all together, it has to equal to 344. So it's y plus 31 plus y plus 31 plus y is equal to 344. Unlike the other problems where we could sort of do shortcuts and some of them you don't have to do this really long equation, yeah, you have to do this really long equation for this one. So combining like terms, I have 3y's plus, what is that, 62 is equal to 344. I go ahead and now I isolate my variable. And so I get 3y is equal to 344 minus 62, which is equal to 282. And then I can go ahead and I divide by 3, basically just to cancel this out because that equals to 1. So we get y is equal to 282 divided by 3, which is equal to 94. Now, if you notice, none of these questions here said, what is y equal to? Because you don't have to figure out what y is equal to. You have to tell me what QR is equal to. You do need y for that, but we can go ahead and now use this to get my final answer by plugging into, what is it, QR. So QR is y plus 31. So that's what I'm going to plug in, y plus 31. Y is equal to 94. It's a pretty easy plugging in. And so what is that equal to? 125. Oops, sorry, I totally put degrees, and that is not correct. We're talking about centimeters, okay? So I have my two answers, 125 centimeters. All right, so there you go. That is the last example for isosceles. Once you get to the other video of equilateral, it'll be very similar, just a little bit different rule. And then the last video is going to be both isosceles and equilaterals. And that's actually a pretty, I think, interesting video because you start getting way more complicated and you have to get really, really creative.